let's just take a look at what we're doing, what we have done, what we started. So in this section, we're going to start talking about those trig functions that I know you guys are really excited to learn about, or not. And before I even talk about that, I'm going to talk about the Pythagorean theorem, which I'm sure you've heard of before and worked with. We've talked about this very special side of a triangle that we call the hypotenuse. It's the longest edge of the triangle. And we said that if we add up the other sides and square each individual side, add them up and then see what that number is, it'll be the same number as if we take the hypotenuse and square it, right? Now we did a little example at the end of last class to find like the missing side of the angle. How comfortable do you feel doing example number 2? I think we can try that. So if you don't remember what we did last class, just take a peek up at example 1, but I'll give you a few minutes to try example number 2. They're still working, but I think most of you guys are on the right track. Let's just go over this one real quick here. We have a triangle. There is a missing angle to it. A little bit different than the one from last time, but Andrew, do you kind of want to take us through your steps here?
So first I figured out what C were. So A and B would be 6 and 3. So I got 6 squared plus 3 squared equals C squared. 9 is 6 squared plus 36 and 2 squared equals 6 squared. And I added them, got 45 C squared. Get the square.
Perfect. Yes, do you need the notes from last time?
No, I don't.
Good. All right. So Andrew did a great job of doing this. I did talk about positive and negatives here. Technically, there is a plus or minus next to the 45, but we said that we didn't need it because side angles can't be negative, right? We can have a negative length of a table or something like that. So Andrew did a great job of showing his work there. Any questions on example 1 or 2? Yeah. Yeah, talking about notation here, one thing I would do is keep it as the square root of C squared, which is C, right? So C does equal the square root of 45 at the end. As long as you get the square root of 45, I'm good. But good question there. Any other questions on example 1 or 2? Sounds good. All right, let's go to the next page here. Now, I told you that there was a very special name for the longest edge of a triangle, and we called that, what was it called again? Started with H. Hypotenuse, right? So on these two triangles, we know that there's special terms for this. Hypotenuse on this edge, and there's hypotenuse here. And what I didn't tell you is there are names for the other sides as well, okay? Now, I didn't tell you this because it's kind of confusing. It's not just, oh, you look for the longest edge of the triangle and that's what it is. The names of the other two sides actually depend on the question that you're being asked. And very specifically, it depends on the angle that you're looking at, okay? So here I have the same two triangles, but I'm gonna label the other edges differently because in this triangle, I'm focusing on one edge, and on the other triangle, I'm focusing on the other angle, okay? So if I'm focusing on one angle, I'm gonna label it one way, the other angle, I'll label it the other, and I think it'll make a little bit more sense, okay? The first angle I'm gonna talk about is called the opposite angle, okay? Or the opposite edge, okay? And it's called the opposite because if you take the angle that you're looking at, that you're focusing on, and you just look at the opposite edge it's on, the opposite is that edge. So this edge is the opposite. Okay. Now on this triangle, on the green triangle, it's a little bit different because now we're focusing on this edge or this angle. And if you go look at the opposite edge from there, well, the opposite is now down here. Does everyone kind of see how the opposite comes about? Okay. Now, the name for the next edge is called the adjacent. So adjacent. Okay. Now that sounds really weird. I don't know if you've heard the term adjacent being thrown around. For example, Paige is adjacent to Sarah. They're sitting adjacent to each other. It just means next to. Okay. So adjacent side is the side that is next to or adjacent to the angle that we're looking at. So this angle's here, this one is right next to it, okay? Now, on the other hand, if I'm focusing on this angle, the side that is adjacent to or next to this angle is this one here, okay? So this is the adjacent side there, okay? So I know the terms seem weird, but they literally mean exactly what it's saying about the angle, okay? The opposite is on the opposite side. The adjacent is adjacent, okay? All right, so let's go to the dreaded trig angle or trig functions here. There are 6 very important trig functions, okay, that we will focus on during this class, okay? I'm sure you've heard of the sine, cosine, and tangent before. You might have heard those terms being thrown around before. And the way that these are defined is literally using a right triangle, okay? So given any right triangle, if we focus on, say, this angle here, the sine of that angle is the length of the opposite side over the length of the hypotenuse side. Okay, so you're just going to take those lengths and divide them by each other. Okay. The cosine is the adjacent side divided by the hypotenuse side. And the tangent is the opposite side divided by the adjacent side. Okay. Now, who remembers the way we remember this? Yeah, so good. I don't know if some of you have heard this before, but the way that some people remember it, I actually wasn't taught this in high school. There's this thing called Secant, and it's kind of just easy to remember it. Sounds catchy, right? And what this stands for is that the sine is the opposite over the hypotenuse, okay? The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent, okay? So I think it's kind of easy to memorize those 3. Now you're probably wondering what the other 3 angle functions are. You're like, what is this cosecant, secant, and cotangent business? I don't know what that means. And you can memorize what the definitions of those are, but I kind of like to see the relationship between these guys, okay? So what I would do is definitely memorize the 3 sine, cosine, and tangent definitions. So I would definitely memorize these. The other ones you can kind of know based on the other one, okay? And I'll try to explain this a little bit better, okay? Sine and cosecant, or CSC, has a relationship. Does anyone see how these 2 are related? Kind of like the inverse, right? You flip the 2 numerator and denominators, right? So the sine is the opposite over the hypotenuse. The cosecant is just the opposite. It's hypotenuse over opposite. So we flipped over, okay? So you don't really have to memorize that cosecant is hypotenuse over opposite. You just have to know that sine is the opposite of cosecant, okay? So you just flip the numerator and denominator. Same thing with the cosine and the secant, okay? These 2 are related in the same way. You just flip the numerator and denominator and you have the secant, okay? Tangent and cotangent are very similar as well. So take tangent, flip it over itself, and you'll get the cotangent. Okay, so you definitely have to know what all of these are or be able to find them, but you really only have to memorize sine, cosine, and tangent, and that's pretty easy because you have the SOHCAHTOA, okay? All right, let's go down to this next part of the notes. In this class, we're going to learn a lot of things called identities, okay? And what these are just relationships between these sines, cosines, tangents, and stuff like that, okay? So any sort of relationship between these functions, we're going to call an identity. And we kind of already talked about this, okay? Let's try to see what these identities say. The first one says that sine is 1 over cosecant. Why have we already talked about this?
saying that they're like reciprocals of each other, so if it's a reciprocal, just do like reverse.
Good. I like the term that you use, reciprocals. I think we talked about the reciprocal before, but reciprocal means flip over the numerator denominator, right? Basically, what this is saying is, yes, sine is 1 over the cosecant of something, but it's also saying that sine is the reciprocal of cosecant, right? If I take the numerator denominator, flip it over, I'll get the cosecant, okay? Now, cosine is the reciprocal of secant, tangent is the reciprocal of cotangent. Now, I have these cosecant identities, secant and cotangent. I'm going to tell you, you only have to know the top three. And the bottom three kind of are the same thing. Does anyone kind of see why?
The other one just put it into another one.
Yeah, right. The bottom ones are literally the same thing as the top ones. So it's literally the cosecant related to sine is the same thing as the sine related to cosecant. Let me just give you. Okay, so only memorize the top three reciprocal identities. The bottom three are literally saying the same thing as the top three. So it's not going to be useful if you memorize those. Okay. All right, so let's go do an actual example and see how we can actually do this a little bit more systematically. Okay, so it says that theta is an acute angle, and we have what the cosine is. We want to find the values of everything else. All right. Well, looking at this question, I already know that cosine is 3 over 4, so I know the answer to this one, right? It's given to me. Okay. Well, let's try to see what we can do. I know that these functions are defined in terms of a right triangle. So maybe I should just draw a right triangle, right? That's a good idea. So I'll draw a little right triangle. I'll put the right angle here, okay? And because we're looking at the trig functions, I do have to zone in on an angle, okay? Now, traditionally, the angle that we zone in on is on the bottom left, okay? This is because my angle is being drawn in like that standard position that you might have heard of in the last section. You can draw the angle up top, but just to keep things consistent, I'm going to keep it on the bottom left. Okay. I know that the hypotenuse is the longest angle. Okay. I'm going to give you a little quiz here. 1 or 2, which one is the opposite? 2, right? 2 is the opposite angle. Okay, which means the last one is the adjacent. Okay. All right. We know that cosine is 3 over 4. Can someone tell me what the definition of cosine is?
Adjacent over hypotenuse.
Good, adjacent over hypotenuse. Okay, so when I take a look at this right triangle, I know that the adjacent edge is length 3, and I know that the hypotenuse edge is length 4. Okay, so let me just label what these are up here. I know that the adjacent is 3, and I know that the hypotenuse is 4. Okay, now if I want to find the other angles or the other trig functions, I'm going to have to figure out what the opposite edge is, right? How should I figure that out? Yeah, the Pythagorean theorem, a squared plus b squared equals c squared. So a squared plus b squared equals c squared is going to allow me to be able to figure out what the other edge is, okay? Now, it's going to change based on whatever angles that you're given. Which ones are a squared and b squared? Or which one is a and b? Not 4. Yeah, okay, so 3 could either be a or b. Let's just make it a, okay? So 3 squared. The other one we're looking for, because that's the opposite. And remember, the hypotenuse is always the one on the right-hand side, or the c, right? So we're going to make 4 equal to c. All right, let's do 3 squared, that's 9. We have 4 squared, and that's 16. Okay, I want to get b by itself, so maybe I should subtract 9 on both sides, right? That's a good idea. I'm going to use a different color here. -9, -9. So b squared is, I'm going to have to look at my notes for this because I'm very bad at doing arithmetic in my, is it 7? Good. Is it 7? Yes. I must have done this wrong in my notes. Wow. This is very sad. Yeah, I did this wrong in my notes. This, these are my notes from last semester too, so I must have realized I messed up last semester and I didn't change it. That's okay. I'll just have to make some note mistakes. Okay, and then how do I get b by itself? Square root both sides. So we got the square root of both sides, and we're left with b equaling plus or minus the square root of 7, right? But we know that the negative one doesn't matter. So I know that because b is square root of 7, the opposite side is the square root of 7. All right. So now we can start constructing what our sine, cosine, tangent are. Can someone tell me what sine of theta is?
Square root of 7/4.
Perfect. Square root of 7 over 4. That was easy, right? It's opposite over hypotenuse. Okay. Let's do tangent. Can someone give me what the tangent is? Square root of 7 over 3. Good. All right. Just using the definitions. Now, let's talk about the cosecant and cotangent. The cosecant, what would the cosecant be? 4 over square root of 7. Okay. Now let's talk about this real quick. If you give me 4 over the square root of 7, I'll actually take off a point, maybe half a point. And why is that?
Don't remember what I knew was bad.
It's bad. Yes. Normally in math, we don't like square roots in the denominator because if you kind of think about it, if you're dividing a pizza, you're dividing something. You can divide something in half and thirds and in quarters. Yeah, dividing by a square root, like you can't divide a pizza by like 3.14159 and it goes on forever, right? That doesn't really make sense. Okay, so because of this, we're going to have to do this thing called rationalizing the denominator, which we have done before. But let me just write out this for your notes, and maybe I'll make it neater. Can't have a square root in the denominator. Okay, so how do we make the square root go away?
Multiply by the square root of 7 over the square root of 7.
Perfect. To undo something in the denominator, you just take that square root and multiply it by the top. Oh my goodness, did not mean to do that. By the top and the bottom. Okay, so you're just going to multiply by the square root of 7 over the square root of 7. Okay, now it's very tempting to like do this. Just cancel off the square root of 7. But if you do that, you'll be left with what you started with. So don't cross anything out. Okay, just multiply across. We have 4 square roots of 7 on top. And what's going to be on the bottom?
7.
Just 7, right? The square root of 7 times the square root of 7 is just 7. Okay, so this is actually what the cosecant is. All right, any questions on this one? All right, the secant is kind of this easy, right? You just flip over the cosine. So this one's easy. It's just 4 over 3, right? And then the cotangent is the same way. We're going to do 3 over the square root of 7. Is that my final answer? Yeah. No, right? What do we do? Rationalize, which means we multiply by the square root of 7 over the square root of 7 again. Don't cancel anything out because you'll just be left with what you started with again. So we have 3 square roots of 7 over 7, right? All right. Any questions on example 3? All right. I think I feel pretty confident with you on example 4. How about I give you a little bit of time to work on the next example? It's basically the same thing, and then we'll come back in a little bit. All right, so let's come back to the front here. In this example, we're doing a different example where we're given what sine is instead of what cosine is. Let's just go through this one. Who do I get to write up the? Oh, Ainsley, do you want to talk through how you got like the missing side length and things like that? Mm-hmm. Mm-hmm.
So I think the hypotenuse C, there's something a squared plus 1 squared plus 2 squared.
Mm-hmm.
Which equals a squared plus 4 equals 4. A squared equals 2.
Perfect. So you got the other side, which was the square root of 3, which is great. Next, we have to find what sine, cosine, and tangent are. Was it Caitlin?
Yeah.
Yeah. Okay. Do you want to take us through this one?
So the question just gave us the 1/2. So I'm looking at the cosine, just know it's adjacent over hypotenuse. It's grab the square root of 3 equal to 2.
Mm-hmm.
And then tangent, the same thing. So opposite over adjacent, and then there's a square root in the bottom. So you have to multiply it.
Perfect. Pretty good finding sine, cosine, tangent. Then we have to go and find the other ones, right? So Marissa, do you want to take us through the rest?
Yeah. So I started with cosecant, and then I just flipped sine so I can get to just 2.
Mm-hmm.
And then for secant, I flipped it, and then I realized I had to rationalize it more. So I got 2 squared root of 3.
Mm-hmm.
And then for cotangent, I just flipped the tangent and got the square root of 3.
Perfect. I do want to talk about the cotangent real quick. Marissa was, I think Marissa found out, okay, there were 2 options to find the cotangent, right? You could have started with this one, which Marissa did, and flipped it over. But we actually know that the tangent is root 3 over 3. So why didn't Marissa start with the root 3 over 3 and then flip them over that way? I mean, you could, but.
What was the question?
Oh, okay, so there were 2 options here, right? So we could have started with the 1 over root 3 and flipped it over, which is what Marissa did. And then another option would be to start with this one and flip it over. Which one is easier? The first one, right? Why is it easier? Yeah, with the second one, you can do it, and I wouldn't like take off points or anything, but let me just show you what would happen if I started with the root 3 over 3 and flipped it over. It would be 3 over root 3, right? And then now I have to rationalize it again, right? Which Marissa didn't have to do in her version, okay? So then you'd have to do root 3 over root 3, multiply through, and you get 3 root 3 over 3, okay? Wait, that doesn't look like what Marissa got. So why is that the same answer? Yeah, there's a 3 on top and a 3 on bottom. So you'd have to cross those out and then get the square root of 3. So you can do the second way, but it's just a little bit more work. I recommend doing it Marissa's way. All right. Any questions on example number 4? All right, then I was hoping to get started on something else today, but let's just do the quiz review. Sounds about right. Okay, next class, I do want to tell you something. If you don't plan on coming tomorrow, you might want to take a paper plate from me, okay? We're going to do a little activity with the unit circle. So if you want one and you don't know if you're going to be here tomorrow, you might want to take one. Okay, and I think it's about time for a quiz review.